Hi, it's Doug
Hi, it's
here.
Doug here.
Can
Hey,
you
Doug,
guys hear
can you
me?
guys hear me? Yes.
Hi.
Hi,
Hello.
Hi, everyone.
everyone. Hey, Doug, are you recording this?
I don't think
I
so.
don't think so. It says someone's recording it. Just trying to see how to do that.
I'm recording at the moment. Do you need it? I can give you afterward.
Okay.
I can send you, but it's gonna be a big file.
I have someone that can't make it that I was going to record it for.
I think there's a recording button at the bottom.
Where is it?
There's a recording button at the bottom if you want to record it.
Oh. Let's see.
Can you see my screen right now?
Where does it say record?
I said, could you see my screen right now? It's fast. It's called. Can you see the PPT screen?
Yeah, I can see it.
Yeah, I can show you what the button is. Here. See here.
Oh, I don't get it there. Huh.
Yeah. Got
It
it?
doesn't show up on,
You got it right?
it doesn't show up on mine.
Oh, I know.
Yeah, I don't see it.
You didn't see the GoToMeeting control panel?
Nope.
I have that.
Can you see my GoToMeeting control panel right now, right?
Yeah, actually, I have a button that says this session is being recorded. Am I recording it?
Yeah, I saw that.
Yeah, do you want to record it or you prefer not to record it? It's up to you guys. I don't mind.
Doesn't matter to me. I'm not really sure
No, it's fine.
much about how this works.
How
Yeah,
about
I don't get that. I don't get that record button.
here?
I don't have that control panel.
The GoToMeeting panel down the bottom, just above the meeting ID. Could you see?
Hi, can people hear me?
I can hear you. Yeah.
Hey,
Yes.
Jimmy. It's guys, Dr. Dalal.
Hi, Doc.
Hey guys.
Hi, hello.
Hi there.
We're just trying to figure out this how this GoToMeeting works. I haven't used it that much.
We use this actually quite a bit at the hospital.
Do you?
Yeah, it's an easy way for people to kind of meet up when they're in different locations.
I'm trying to record it for Goddard. How do I do that? You wanted me to record it.
I can take you.
That I don't know. I'm not sure if I've seen that done before.
Yeah, because it's not showing up.
Let me because I'm actually recording it. If you really want, I can send you the file. But
The bottom of my session does say this session is being recorded.
yeah,
Yeah, that's
Yeah.
my
recording. Yeah, I'm recording.
I need to record it. Who are we waiting on? Doug, is it George and Dave?
Well, George and Dave were on the list there, and George didn't the one who invited me, so I'm assuming they're coming.
Okay.
I only have till 3, so hopefully they're coming soon.
Oh yeah, because I got Jimmy to pipe in from Australia, so hopefully I'm gonna text him right now.
Okay.
They're also starting out.
See?
I somebody sent a message.
Can you see my screen right now?
Yeah.
Yeah, I've highlighted the location of these two buttons. Can you see that?
Yeah. Oh, right there.
Okay. You saw it, right?
Yeah.
Yeah, I'll close it. Okay.
How's the weather out there?
In Vancouver, terrible.
Yeah, dreary and wet.
Oh, there.
I'd like to say Australia's better, but Sydney is quite wet right now. But
Is it?
Vancouver is much better than Calgary.
What's Calgary snow?
Well, yeah, I'm in Calgary. It's cold. It's really cold outside.
Yeah. Doug, do you know if Rick was coming on the call?
I didn't see any answer from him, so
Okay. Okay, we'll start in 1 minute, Lauren.
Yeah.
Chip, you're gonna get going right too.
Okay. Should we start right now?
Yeah, just give it a minute. I just texted him.
That might be busy. I think George and Dave have seen this a couple times in the past.
Yeah.
yeah. I was looking at some of the Dropbox stuff. It looks like they've been close to this a fair bit.
Yeah. Oh yeah, let's just start and then they can come in. If they come in, they can join because I think they've seen it quite a few times anyway.
Okay.
I have not.
Yeah, I mean,
Yeah, I think we can just start and then see whether they can join the song in the middle.
Sure.
Yep.
Okay, let's start. Okay. First of all, thank you everyone for being here, especially Fab and Doctor. The first time we talked to each other, and the product I'm going to show today is called Fast. I think you guys might have some information about this product. Today I'm going to give you some details, technical details, and the business details about this product, the background, whatever, everything. And I'm the main developer behind this product right now. So basically, so what the Fast is all about. The Fast is an intelligent solution to help doctors to make decisions about people and patients with stroke. So let's start with some background information. So what is stroke? I think doctor will have a lot of information about this, but the rest of us might not be experts. So I'm gonna take some time to explain the big picture. So stroke is a sudden interruption in the blood supply of the brain, and may cause permanent brain damage or even death. Well, I think some of us or all of us have seen some stroke patients in our lifetime. I have some relatives who have stroke. I'm sure you guys will have some people you know who have stroke. So it's a common problem. So 1 in 6 people in the world will have a stroke in their lifetime. Maybe, I think in the US, stroke costs USA is about $34 billion each year. It's about $100 billion worldwide. So these are just statistics. So it's a big problem and it affects a lot of people. So how to treat stroke? Again, I think doctor would know more about this than me. But again, just give you some information from my view. So the first couple of hours are crucial because if the blood supply is cut off, the brain is dying, or at least a part of the brain is dying. So time is everything. So that's why first couple of hours are crucial. It's not like cancer. Cancer will give some people some time, maybe days or at least months or even years. But stroke is not like this. It happens. If that happens, they need to be taken care of very quickly. Otherwise, very serious consequences may happen. And also, it takes time for patients to know they have a stroke, and then it also takes time for patients to be transported to the hospital or to medical center to be treated. So again, the high quality of the stroke treatment is dependent on promptly and accurate diagnosis. So you know the situation, you know the condition of the patients, and you come up with a treatment plan properly. So medical imaging is the most effective means to diagnose. First, because when you have a stroke patient, you got to know the condition of this patient, right? And then the most effective way to do this is actually using medical imaging, mostly CT. So the problem with this approach is actually doctors are forced to make a decision in maybe a few minutes, as soon as possible, because patients may be dying. And also, interpreting this image requires great expertise. While interpreting this medical images is not a simple thing, and then especially for the stroke, you have basically when you have a CT scan, you might have hundreds of images to read, and then read them one by one. It takes time, and also it takes expertise. So most medical centers worldwide lack the internal expertise to do this, to have the job done. So again, the situation is like this: the patient is dying, and the doctor is forced to make a decision as soon as possible, in the shortest time possible. But to make that decision, you need to have great expertise. But not everyone has this kind of expertise in the world. In fact, some doctors may have, but most doctors, they are maybe just average in reading these medical images, especially the stroke images. So that is basically the logic behind this product. So what do we do? Stroke, the FAST is an AI-based system to help doctors to make these decisions. So basically, we interpret the image for the doctors. So it's like AI solution, erasing all these medical images, erasing all these CT images, all these CT scans, and then do some detection, do some image processing, and then give out where the location of the stroke is, how big it is, and these pieces of information will help doctors greatly. So it gives second opinion. It's not something to replace doctor. It's going to help doctor. Right? I think doctor, you have seen some of this in your maybe hospitals. For example, the mammography, or even the CAD, the computer-aided detection system to help doctors to find the early sign of lung cancer. So the FAST is for the stroke. Okay, they process 100 images in a few seconds. Maybe not about 20 seconds to 30 seconds, depends on the workstation, the processing power of the workstation. But usually under a minute, which is much faster than human readers. So human readers, depends on their expertise, may take 5 minutes to 15 minutes. So it's multiple times faster than the human reader. So software could be attached to the CT scanner or PACS server. So it's not a standalone medical device, which needs maybe extra installation. It's not like that. It's just pure software system. So it can be installed and it could be integrated into their daily workflow. There's no need to change their workflow at all. So it's easier for doctors, easy for users to use, and easier for users to install in their workflow. So again, this is basically using the AI to help doctor is not a new idea. It's not. You can see the AI-based medical imaging market, that is prediction, from 2017 to 2022, 2023. That's $1 million. That's $1 million, about $20 billion. So okay. Also, there are a few AI medical imaging companies, and the one at the bottom is our competitor, and which is called Brainomix, and the one above it is called Circle Cardiovascular Imaging. That is a company in Calgary as well. They're doing pretty well these days. We have some connection to their company, and then they know me, they know us, and we know them. You can see the future for the AI-based medical imaging is great. So the target market, who will be our users, right? Who will be our customers, hospitals, or targeting customers, including hospitals that have CT scanners and telestroke companies. Telestroke companies like this because a lot of medical centers in the world, they don't have expertise to read these stroke images, so they can hire someone in remote to help them. So they connect from remote location, and then they can read these images to help these medical centers to make decisions. But once again, even the people in the telestroke company, they need help. Also, another group of customers are biopharmaceutical companies and technology companies. When they develop drugs and equipment to treat a stroke, they will need help from us. So again, the business model, yearly subscription based because it is pure software system. It's pure software, no hardware involved. They can install system, they can install software on their computer easily. So we can use yearly subscription based and then charge them something yearly. It's kind of industry practice. A lot of companies are doing this. And also flexible pricing means we can charge them by the site, by location, or by number of patients to have scanned, things like that. Also charged by per installation or per site. Per site is like a package. You can install as many copies as possible in a certain hospital if you buy per site license. And also we're gonna sell it through maybe channel partners and distributors. Because we're a small company, we are currently focusing on the development. So development will be our main focus. So we would like to, at least in a short period of time, leave the sales and marketing to other people, professional people. Okay. Let's talk about a little bit about competitors. There are two main competitors in the market. One is SchemaView. This is a company in the US, founded in 2006, and they got FDA already for CTP-based rapid software. CTP is different from CTA, so it's kind of competitor, but it's not a direct competitor. It's kind of two different competitor working in a different modality, different kind of CT images. Another one is CTP, is basically CTP for the company, but they're moving toward our territory, which is CTA, CT angiogram. But they're working slowly. So there are also many other CTP companies like SchemaView, but SchemaView is maybe the biggest competitor these days. Another one is...
Sorry, quick question.
Yeah.
CT pilogram or...
Pardon me?
Is the CTP CT pilogram?
No, CT perfusion.
Okay, a perfusion scan. Okay, thank you.
Yeah. CT perfusion, let me explain a little bit more about this. CT perfusion is different from CTA. CTA is like you inject some contrast enhancement agent into the body of the patient, right? And then you take CT scans, right? CT perfusion is more complicated. It doesn't inject once. You inject contrast agent multiple times, and then you take multiple images. I mean, multiple scans. They take multiple scans. When I say multiple scans, it means thousands of images sometimes. So for the CTA, you're probably going to take hundreds of images, but for CTP, you can take thousands of images, and then you can analyze the dynamics of the flow of the contrast agent in the patient's brain to determine the damage. But it's going to take a lot of time. It's very slow. Maybe 10 to 20 minutes. So usually it's not the first option for stroke patient, especially acute stroke patient. It's usually used to assess the damage after the treatment or when the condition of the patient is stable. So that's why I said it might not be the direct competitor at all. So again, CTP is usually not for emergency room doctors. So Brainomix is our competitor actually. That's a company in the UK and started in 2010. They got investment around $10 million. It's a CT-based solution, and it has eCTA launched in 2016, mid this year. It's also a pure software system. But we are different. We are different in terms of technology. We are very different at all. Let me show you the difference. Where it is here. Could you see the image on the left? These ones are 2D images. Means you see these images scan by scan. There will be hundreds of them, at least. So you take these scans and then you trace the blood flow, and then you trace the artery yourself, and then try to find where the clot is. So, well, it's a kind of very tedious and it's difficult. It's a difficult process. Usually it may take about 5 to 10 minutes. Depends on expertise. Sometimes could be 20 minutes. Depends. If you can find them. In many cases, they couldn't find it at all. Can you guys find where the location is of the stroke from the images on the left? No, right? It's actually on the patient right. It's at the left of the image. And also the full image on the right, that's our solution. We are 3D solution, you can see, right? There are 3D solutions.
Yours on the right? Laura? Yours on the right?
Yeah. I see. Could you see where the stroke is, or whether the affected area is, right?
Oh, so when you're reading these, you're reading it opposite. So what's your right is the patient left.
I know. It's from
So for that.
It's bottom down.
Oh,
It's
really?
from it's seen from the feet of the patient to the top.
Okay.
So it's scanned usually from the heart all the way to the top of the brain. So development. These are some technical details. I may go through them very quickly. To do this, basically it's a complicated process. We are doing something like to imitate the process of human expert, right? We human read images very quickly. We make decisions very quickly. Everything is instant. Well, but to design a computer program to do this, there are multiple steps. There are a lot of steps. There are a lot of algorithms involved. The first one, for sure, is image processing. You're going to process the original image because the quality might be different, or the location might be different. A lot of things might be different. So you're going to do some normalization, make sure every scan or every study is the same. So not kind of same, but within the same range. So the computer algorithm can process them relatively easily. So it has multiple steps, including normalization, noise removal, registration, registration is the most important thing. In terms of noise removal, these days CT scanners you don't see a lot of noises from a standard CT scanners these days. But registration is different. Registry because there may be rotation, the scaling issues in terms of the patient images. So another one is occlusion detection. That is find where the stroke is. After that, you can measure the size of the stroke, where the blood clot is, and you can do some other processing like thinning, which is putting the 1 pixel length, and after that you can use computer algorithm. One pixel width. So computer algorithm actually trace these lines to find where the stroke is. It's kind of similar to the human process. And it also has GUI and PACS interfaces. GUI is something for user to use because occlusion detection and image processing, there are things happening in the background. They're not something people will see. From the user point of view, they see the GUI, which is graphical user interface. They just see the interface. They click the button, and the software is supposed to give them some information about the stroke. So GUI, which is something working with users directly. The PACS interface is how you're gonna integrate your system into the hospital, because hospital have their workflow. Hospital have their image servers, and our system is supposed to work with them perfectly. So that's why our system needs to talk to the PACS server. In this case, that's why we have PACS server interfaces. Also there are others internal tools, because when we do the development, right, we can then pass some algorithms, we can do some image processing. That may require different tools to help us out. So again, the occlusion detection is fine. The tracing, we started from the ACA artery, and then same method could be applied to the PCA artery, MCA artery as well. But we start from the ACA because a lot of stroke happen in the ACA. And then you have tracing the ACA to find tracing the artery to find where the location of the stroke, and then we have the stroke detection algorithm. If the blood supply is cut off from is disappearing from the image, we will use the clot detection algorithm to find out what happens, whether it's because of a blood, whether it's because of a clot or because of something else. The registration is also a very important step. It's probably one of the most important steps in the image processing, because patient image may have some rotation, scaling, or scaling issue, and then images need to be aligned for segmentation, vessel tracing, clot detection. Means the registration is the first step, and after that, all other things can actually happen. So that's just why it's very important, but it's also very challenging, because if you try to align hundreds of images, it's not an easy thing, and then it's usually a very slow process. It might take minutes, but you're supposed to make a decision in under a minute, right? If that procedure takes minutes, your system is already slow. You don't have a lot of time left to do other processing steps. So registration has to be accurate, and it has to be really fast. So these two are the biggest challenges, because they are contradictory. They're working against each other. But we got a solution for that. Our registration is very fast. You can see the one on the left, and that is before the registration, and the image on the right is after registration. Basically, rotate a tiny little bit, but all the other things. Doctors, do you have any question?
I will after, but there's one on the chat there.
Yeah, I was typing. I didn't want to interrupt you, so I was typing a few questions in as I was listening. So my first question is this considered a cold read, or does the emergency physician or radiologist or even the EMS have the ability to input? Okay, there's left side deficits, there's right side deficits, there's a droop on the left eyelid, or there's a pronator drift on the right. Does this take into account any clinical information?
No, just based on the images only. No, it doesn't need any input from expert at all. Basically, just kind of AI. Erasing the images from the scanner automatically, and it gives out information to people. It doesn't need a lot of input from the experts. No, not at all. So this is fully automatic.
Oh, I understand that it is automatic. Is there an ability? Will that increase its effectiveness by adding input, or is that not something that this is set up for?
No, it's not. That is not this set up for. This is to give very quick suggestions. It doesn't replace you. It gives you some information, tell you what it is, how big it is, and after that, based on the information that our system gives out, and then you can make a decision yourself. You can write out, okay, this is not something I would like to ignore, or that is something I will take it very seriously.
Okay, and will it? What is the minimum computing power required? Is this going to require hardware updates to radiology?
No. Just the average computer can do the job. Just average computer. Maybe a workstation with 4 cores, 8 cores at most. The more the better. But 4 cores, 8 core is kind of computer people use every day. It doesn't require some very scary computational power. It doesn't. That is all power actually. We designed some sophisticated algorithm to make things faster and accurate at the same time.
Okay. My last question is, does it differentiate between ischemic strokes and hemorrhagic strokes?
Not at the moment. Just ischemic stroke, not hemorrhage. But we could add this, because hemorrhage is easy to find, right? I suppose.
It's easier to find, but that's not differentiated. We can't make a clinical decision then. So even if there's a small bleed, if we don't know for 100% sure that there is no bleed, we are then unable to act and give a thrombolytic because that can make it worse. And so quite often we wait on the radiological reading, not just to say, yes, there is a stroke, but to also say, no, there's no hemorrhagic stroke.
Okay, no problem. In terms of the algorithm, hemorrhage detection is our roadmap based on first step, because this thing is kind of a different branch. Hemorrhage detection, we have the algorithm for that, but it's not simply not here right now. We will add this part of in a later stage. But again, we got the algorithm because it's not that difficult from our point of view. I know because if you don't know whether it's hemorrhage, if you inject some CDP, if you inject some drugs, and then they might make the bleeding worse. People may die, right?
Absolutely.
Yeah, I know.
Okay, thank you. Those are my questions.
Okay, thank you. Again, we have the algorithms for that, but again, that's a different branch. We can follow this branch first, have it done, and then we can move to a different branch because they require different algorithms, different processing steps. Okay, this is the registration process. You can see, and there are the first three images on the top. They are not perfectly aligned, but 3 images, and on the bottom they're pretty well aligned. These again, these are just illustration. You don't have to understand this. It's just happening in the background, happening within the algorithm itself. Stroke detection algorithm, again, using different tool. There's a vascular tree on the left, and then there's after processing. There's a thin algorithm because the width of the vessel is not important for our algorithm before the detection happens. After detection is very important because we can determine the size of the stroke. But to find the location of the stroke, it is not that important. Also, these are the trace algorithm. We trace the vessel on the left and on the right, and then you can see more vessels on the patient. I believe this is patient right, yeah. Because I have rotated actually. I have rotated a little bit. Okay, so this is our interface. This is something people will use, and this is something people will, the doctors will use every day. Again, you can see this MRI images, right? This is not CT scans. Just for illustration. You can see you have multiple windows, different views, and then this is, another design. Just like different color. I can give you a live demo after this. These are just snapshots. Again, regulatory issue, because when we have the development done, so we're going to go through regulatory before we can sell this one on market. So again, there are multiple of them. FDA, maybe European CE, kind of Canadian ones. Let me talk about Canadian ones first. Canadian one is very similar to CE, and then third-party registers. You don't have to do everything deal with the government directly. Governments are slow, so we're gonna work with some third-party registers. And then there are multiple manufacturers class 3 to 4 satisfy certain requirements. We are actually class 2. So the class 1 is like scissors, surgery scissors, things like bandage, things like that. Class 2 is like medical, maybe a diagnosis software, things like that. There are some risks, but not big risks. So it's risk-based. So class 4 means there might be life-threatening, mission-critical things. But like class 2 is just kind of average thing. These are the chart diagrams you can follow to determine which category your product falls into. But again, we belong to class 2, second easiest to pass, which is non-invasive.
Our target market is not the government. Our target market is third-party consumers.
No, they are third-party registers. Means they help us to get approval from the government.
Okay.
Sell this, right? This medical device, we cannot sell it in the supermarket, right? We can sell it to hospital. So the hospital will have to ask, well, do you have the government approval? You can answer, yes, I have. So in order to get that government approval, you're working with third-party registers. So you don't have to work with the government directly because they are slow. But the government have a certain permission to some registers, so they can issue you market approval directly. So that is the pretty much like for your car plates. So we belong to class 2, which is second easiest to get. Maybe above surgery scissors, but certainly much easier than maybe pacemaker or something. So deployment, we're gonna have deploying maybe it has 2 parts engines for detection and GUI for the people to use. So okay, and through DICOM, I think these are the technical because we're running out of time. So let me be really fast. So development, this is diagram or PAX. Our system will be part of the PAX server or connected to the PAX server. So we're gonna communicate when a certain scan is taken, and then we download these images directly to our fast server. We do some processing, upload these images to the PAX server, and after that, users can read these images from the medical image viewer, standard medical image viewer. So we have a user interface, but we could be a part of the PAX server working in the background as well. So what's next? So we have developed all of these modules, but we will still need some time to make more testing. So we're going to improve the interfaces, then do the module integration. But because, as you can see, you have multiple modules, right? We developed them relatively independently, so we need to put them together. Okay, thank you, everyone. And I will give you maybe this one. I'll give you a left done. Let's see what we have done. Can you see?
Jimmy, you would know what that looks like more than I do. To me, it's just a drawing. Or a scan, sorry.
Yeah, this is what I pretty much look at every time we have a scan, although it's slightly different as these has different areas are lit up.
Okay.
This looks like these extended green contrast scan, except they have arteries lit up here.
Yeah. Let me see. No. It's gonna be here. You're supposed to see a 3D. Let me try this one. Maybe because I'm sharing my screen. Sorry for the delay. Yeah. Oh, I don't know what happened this time. Because you are supposed to see something like this. This is a snapshot from this screen here. But unfortunately, the 3D thing doesn't show up. I don't know what happened. Okay. I can give you I can send you more snapshots later. I don't know. Sorry about that. Any questions, Doctor?
No, nothing else comes to mind. I think I asked the questions I was curious about.
Okay. So again,
What What does your competitor do differently, Laura, than you guys, the main competitor?
There are 2D based actually. We should be in the first on market, but because of some issues, we're actually slower than them.
Yeah.
We are 3D based. They are 2D based. 2D based is like this. Let me show the image again.
And I sort of, how do your patents protect against them overlapping?
Again, they are 3D. We are 3D based. We are treating 3D images. They are treating 2D images. We are very different indeed. They are very different.
You mentioned earlier that there's CTP.
Yeah, CT perfusion. Yeah.
Yeah, they're advertising CTA, and they've gotten FDA approval in May.
Yeah.
From what I could see.
Yeah.
Is that any impact to ability to market this in some of the areas, since they're already on the market with their CTP?
The CTP has been around for a long period of time, because people started CTP I think in 1998, around 1998 something, 20 years ago. Actually, there is one guy called Ting Li I worked with before. He is actually one of the first researcher working in that area. So he actually worked for GE in 1998, starting from 1998. So GE has CTP long time ago already.
Mm-hmm.
So it's not a big problem. We are working, well, our modality is CTA. They're different modality. They're different modalities, like different cars. We're working with sedan, they're working with a truck. They're different modalities.
So you're saying your CTA is different than the one you developed?
We are working with CTA, but CTP is different modality. It means we're working with cars, but they're working with the trucks. Yeah. It's not different.
But that's what I'm saying is they're advertising CTA.
Yeah, I know.
I'm just wondering, is it competitive with what you've developed, or?
Brainomics. I said before, Brainomics the one.
Okay.
Yeah,
and these would be marketed to hospitals and that sort of thing. It's not possible to actually market them to like GE or somebody who produces a CT scan and have it built in, or is it?
No, yeah, it's possible. It's possible, but I don't think GE has CTA already. They don't have it. We were the first runner on market, but because of some internal issues, we are slower than Brainomics. But we actually started before Brainomics. We should be in the first on market. We have the technology, we have everything, but because of some internal issues, we are the second right now.
Okay.
I think that would be my concern, is that this AI for radiology is the next big thing, and it is actually looking to almost literally supplant most radiologists to some degree or another. Whoever is first to market will be the one who essentially gets the golden egg. And so I guess that's the question is, once you have not necessarily hospital approval, but health authority approval. So at least in British Columbia, the way our hospitals work is there are groups of hospitals set up into 5 groups across the entire province. And once you have authority for one, and once you have approval for one authority, you then have implementation to all the hospitals or a select group of the hospitals within that. And so where are we in that process?
We haven't started yet. We need to have the product done first. Again, just like the issue that I brought up a couple of minutes ago, we were the first on market. We were first in the area, not the first on market. But because of the internal issues, we actually kind of temporarily stopped. That's why we need help from you guys. We need to make a restart. We have technology, as you can see. We have a lot of modules done, as you can see. But we need some resources to put them together, and then we will get the approval from the government after that.
So where will you be in terms of your competition if and when we get that started right away? Is there any differentiators between you and them?
Again, we are 3D based, we're accurate, we're faster, and because Brainomics, their solution, they will usually take around 5 minutes. But we will take longer.
Is there a deal to be done with them, you think?
Pardon me?
Is there a deal to be done with them synergistically?
I think no. I don't think so. Again, they build everything on their platform. They are 2D based, they build everything on their own platform. Whereas 3D based, from the very first beginning, it's like take very different path. We are taking different.
Okay.
So again, we are competitor in terms of the target market, but in terms of technology, we are very different indeed. We are very different. We give more information to the doctor than they do.
Okay. So how long would it take to actually get a prototype up and running?
A few months maybe, depends on the availability of the resources.
Yeah.
I think
Do you
by
have it?
maybe next year at most.
Do you have an actual basic prototype of any kind, or is this just what you have here?
I got what I have here. Prototype is when we put them together, you got prototype. But again, it's not kind of prototype you see every day, because when we put them together, this is working thing. It's not a prototype. We didn't start from the prototype. This is whatever you have seen today will be part of the final product, will be used to get the market approval at all, or working with them. So we are not developing a prototype. We are developing the product. Once the prototype is done, our product is done. Because when people talked about the prototype, it's like you have a prototype to demonstrate your idea, and after that you throw it away, and then you can start from a product version. It's not like that. For us, we start from a product version directly. So again, it's not a prototype. It's work.
Okay.
So it will save a lot of time, right? Other than
The doctors that were instrumental in developing this, that were on your advisory board, the stroke specialists, are any of them still involved?
I think they're partially. Maybe. That is question you better ask Drake.
Okay. But they were instrumental in developing this, is that correct? In helping develop it?
Yeah, they actually they started from, that is their idea. I'm the developer. I know the machine learning, I know the image processing, but the idea, in terms of this is big market, this is something doctors will use, well, that is from them.
Okay, so they came up with the concept and you developed it.
Yeah, they came up with the concept, they came up with their requirements, and I came up with the technical solution to help them. So it's like they're working from user point of view. I'm working from the technical point of view. So that's why you see. That's why you have seen these.
And they were stroke experts that told you what was missing in the current system, basically.
I don't think so. Because once again, just like what doctor said just now, well, you're gonna discriminate from hemorrhage, gonna know whether there's hemorrhage somewhere. But once again, that's a different path. We're gonna work with ischemia stroke first, and then we can take a different path. They belong to different paths.
Okay.
So
What I was saying is the doctors identified areas that were missing in the current system and just wanted to improve.
There is something they are missing actually, because you're supposed to read this image one by one. Can you see my screen? It's like this. Just trace manually. See? One by one slice by another slice to find the location of the stroke. But we do this automatically in a 3D view. It's like this. But I don't know what happened today, but maybe because I'm sharing the screen, but I'm supposed to show you the 3D view here in the black screen. It's like 3D vessel tray, and then you can see where it is cut very easily. But I can send you guys some snapshots after the meeting. Maybe that's because I'm sharing my screen constantly.
Also, it goes for 3D.
Yeah, 3D. Yeah, 3D image, just like this. Just like. Just like, can you see the 3D? It's actually a 3D thing. You're supposed to see. Can you see on the one on the bottom? There's a red vascular tray. Can you see this? This one. But I don't know, for whatever reason, maybe I'm sharing my screen and that's why this happened. Let me try again. Any questions?
Uh, I think that was how you done. You guys think?
I think that's good for me for now.
Jimmy?
Yeah, I can show some guys some 3D things after the meeting. I can send you an email because once again, maybe because I'm sharing my screen, so that's why the 3D view disappears.
Yeah, if you email me the snapshots, then I can I'll forward them on to Jimmy.
Yeah, I will. I will share a video maybe. I can give you a video. Locate some maybe a YouTube link something. I can upload a video and then you can see 3D view.
Sure.
Okay.
I've got no other questions on my end.
Okay.
Okay, yeah, send those to me then, and I'll put together some other questions as well. Then I'll fill the other guys in and let them know where we're at.
Okay. What do you think, guys? Any feedbacks or anything you would like to see more, or any missing information, any impression?
From what I can see, my limited medical knowledge, I like it. I just have to do some more research on it.
I feel the same.
Yeah. Jimmy, your thoughts, good or bad?
Sorry, I missed that last part. What'd you say, Fab?
Oh, I just said your thoughts, good or bad on it, just from the little that you've seen so far.
No, sorry. What I said is I missed what you just said before that.
Oh, I said due to my limited medical background, I have to do more research on this and other competitors.
So I think from the medical side of this, like the idea is solid. It is something that we sorely need that will expedite this. And when you're talking about a stroke coming into your ER, we're talking about minutes. We keep extending how long we have because we're finding that we could use thrombolytics or clot busting medications. What used to be 90 minutes, now 3 hours, now up to 6 hours. We're still seeing good benefits. But especially in the rural communities where they now have the ability to push these medications, which they didn't before. This is a new thing as of, hell, even a couple of months ago at our hospital. This is something that would be a game changer. But the issue now then is that who are the competitors? Who's going to be first to market to have buy-in from the medical authority? Because once you have that, that's it. They don't change their minds. They don't say, okay, we'll try something else next. Once they make a decision, that's it. They're done. No take backsies. So the big thing for us, if this is going to go forward, is trying to get an edge over the competitor and trying to get first to approval. Once that's done and you have uptake from at least one health authority or one major hospital, you're going to the races.
Okay. Yeah.
So that's my concern.
That's really good. Yeah. Again, we have some very our unique ability, which is kind of 3D thing. They don't have a 3D thing actually. 3D make it much easier and make it much more accurate actually than their Brainomix solution. So that's why we started. Actually, we knew when we started, we knew Brainomix was developing these similar things, but and we knew they're starting from the 2D solution, and so that's why we did some research. We realized if you start from 2D solution, you're never going to be as good as 3D. So that's why we start from 3D. So that's why we directly.
If that is going to be the goal moving forward, that is what differentiates you from the competitor. Is there any research? Is there any papers? Is there any factual way we could show that 3D is better?
No, at the moment. That's why we need some. Again, this is from the algorithm point of view. From the user point of view, you see 2D things, slice by slice. But in terms of background internal processing steps, you got 3D. And we got the option, if that is the option to go, if that is the way to go, we can show you the 3D thing directly to the users. But if users don't like 3D things, we have 2D things to show them. But in the background, we always develop every single study in 3D. So that is our power. So that is we can do things in just under a minute. They might take 5 minutes to process, but we're going to have things done, like scan all these images in under 1 minute on average computer. That is we are much faster than them.
Okay, thank you.
Okay, thank you.
Okay, thanks. Thanks, Lauren. If you can send those emails, then I'll be back to the guys as well, and we'll go from there. Because I know a couple of guys are missing on the call today.
Okay.
So maybe do another one with them.
Okay, no problem. And Doc, there's one more thing. I think in terms of educating the users, because whenever a new concept comes up, it usually takes some time for users to understand it, right, to accept it. So in this case, I mean, if we're gonna competitor maybe slightly ahead of us, might not be a complete bad thing. I mean, they might take their resources to educate the users, to let them know there's something AI-based solution to help them. But if we can come up with something better, if the users they are familiar with the concept through our competitors' channel, well, they might compare them, right? They can compare them. They're gonna see, okay, there's another one. There's another solution. There's another solution. So if there are two solutions, you can compare them. So we might save some resources in terms of the marketing. So it might not be the bad thing, but we cannot be far behind them. Maybe we're slightly little bit behind them. That is still okay. But if we're a couple of years behind them, that is a bad thing. So that is my personal opinion. We will save some resources in terms of educating the user, right? Because people are conservative, especially doctors. They're conservative. If you're gonna persuade them to take some new ideas, it takes time. If our competitors can do the job for us, and then we can sell them a better solution technically, well, there might be a good solution. There might be a good way to go, but there might not be the bad thing at all. That's my personal opinion.
Okay. What do your patents cover exactly?
The whole process, and then we are on the way to file other patents. But once again, just like I said before, because we stopped earlier this year, so a lot of things on our plan, we have to stop. We have to put them aside, so that's why we're a little bit late. But once we have resources to move it forward, we're gonna file a couple of patents in terms of 3D image processing, 3D artery tracing, and the location detection, and then the volume estimation as well.
Okay, but it does protect you right now in some ways from your competitors coming in and do the same thing.
Not at the moment, but I don't think there's another competitor doing the same thing. We're as far as we know, because again the company, the founders, other founders, I mean, from medical side, they are the best in the world in this area. So as far as we are concerned, we don't know any competitors doing this in 3D. So we don't think we're probably not gonna have any competitor very soon. Because once again, Breanomics, if they do 2D, a lot of the guys will have 2D as well. So 2D is way easier than 3D. Because we have this kind of technology, you can do it 3D directly. That's why we are very unique, and we have some unique advantages. But as far as I'm concerned, I don't know. I don't think there's any other competitor doing the 3D. So we have time. We have time to file the patent.
Okay.
Okay. Any questions? Any other questions, guys?
No.
No, I think that's it.
Okay. So what I'm gonna do next is I'm gonna give you guys the video location, a video link about this 3D thing I can show you. I'm supposed to show you right now here, but because I'm sharing my screen, there's some driver issues with my computer, which stops me from doing this. I apologize for that, but I'm gonna give you the video. You can see it. Okay.
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 So the equity from the investor will be for a better video card.
Yeah, exactly.
Yeah, I know.
Better-
Video part. Okay, I heard a video card.
Yeah, we need to be able to share images.
Okay, I know. That's why I'm doing this right now. But again, that is my system's problem. So
Yeah.
No problem.
no problem. I will definitely give you some videos. Okay. Okay.
Okay, thank you very much, Laurent.
Send me whatever you can, Lauren, please. Then I'll forward it to Doug and Sherry.
Okay. So whenever guys have a question, just send me emails. Right, I will answer them. Okay.
For sure, we will. Thank you so much.
Thank you.
Thank you, guys.
Thanks.
Bye
I
bye.
know.